Alright, so in this video we're watching single replacement reactions, and you'll see of the 5 major types there's a single replacement and a double replacement that are similar to each other. You may also hear them called single displacement reactions, and the important thing here to note or know is that for a single replacement, one element replaces a similar element in the compound. So either a metal is going to try and replace a metal, or a non-metal, typically a halogen, is going to try and replace another halogen or non-metal. We say try to because this is the only one where you have to worry about something. So these are the two different types that we have. The first one here is a metal being replaced. So letter A here is a metal, and so it's going to try and kick out the other metal. And remember, metals are positive, so it's in the front of the compound, and in this case it's showing you that it happened. So what happened is now B is by itself and A has horned in and moved in on lovely halogen X. In the second equation, the halogen is being replaced, and remember, a halogen is a non-metal, so it's just group 17 non-metals. So now we have Y, and he doesn't care about B. He's not trying to kick out B. He is trying to kick out X. And again, with these two different types of single replacement, you need to be aware of which type is happening so that you can properly predict the products. And the analogy is basically that if you have a boyfriend or girlfriend that you really like, you're not going to dump them for someone that's mean to you or not as good or not as nice to you or anything. So the analogy is you dump your boyfriend or girlfriend for someone cooler or better, and you won't dump them for someone that's not nice. And how you tell if a single replacement is going to happen or not is you actually have to check what we call the activity series. And that's in your notes, and we'll get to it. One thing you may want to write down about the activity series is the activity series is in the blue test folders. So it's not something you need to memorize. It's not something you need to put on a note card. You just need to be able to use the activity series and understand what it is when we explain it. So we're going to just look at a couple slides of examples of single replacement ones, and then I'll show you what in the world the activity series looks like and how we use it. And that is it for good old-fashioned single replacements. Here's just a couple examples. We have aluminum, and he's definitely a metal. So that means that, again, if you're a metal, you are interested in trying to kick out another metal. So if you look here, aluminum is kicking out lead. And it turns out on the activity series, that's a possibility. It can occur. So what you see here is now lead is all by itself, and now aluminum is hanging out with nitrate. If an activity series says the reaction can go, when you write your products, you need to make sure that you balance all your charges and then balance the overall equation. So you still have all the normal stuff we've been doing. You just now have it in a new situation. This is an important thing here when you're replacing water. When you're dealing with water, think of water as an H and an OH, and it'll be easier to kind of deal with. So if you're looking at the one we have down here, if we think of water as H and an OH, makes it a little simpler to see where this is coming from. So if you remember, we talked about those alkali metals, those group 1 metals, and we said they are really reactive. They're reactive enough to actually react with water. So that's what's happening here. We have sodium, and it's actually reacting with one of the hydrogens in water. And what happens here is this hydrogen breaks free and becomes hydrogen gas, and then sodium moves on in and hangs out with hydroxide, and you get sodium hydroxide. And these are less common just because there's not that many metals that can actually rip water apart. Water is a really strong bond, and as you can imagine, it doesn't come apart very easily. Here are just some other examples here. Again, you have to make sure if it's a metal, you're going to try and kick out the positive part of the compound because metals are positive ions. If you're a non-metal, you're going to be kicking out the non-metal portion of it. And here's just an example of the nonmetals. So here we have chlorine, Well, chlorine is not a metal, it is a nonmetal. So when this reaction tries to take place, he's trying to kick out bromine. You have to check your activity series, which we'll do in the next 3 slides. And you can see that in this case it does happen. So bromine is liberated, he's free, and that means chlorine is going to hang out with potassium. When you do this, you still have to make sure that your positive ion goes first in the compound, your negative ion goes second in the compound. So you still follow all the normal rules. You just have to see if it actually happens. And if you look at the bottom here, here's one where bromine is trying to kick out chlorine. And again, bromine's a nonmetal. He's trying to kick out the nonmetal. But in this case, when you check the activity series, it's not allowed. It's like a no-no. So what happens is exactly this, no reaction. So when you're on the test or when you're doing your practice problems, you need to check these to make sure, can this happen, can this not happen, and actually see what it is. If it can happen, you need to balance it and everything. If it can't happen, you need to write no reaction. And the last little bit on single replacement is the activity series. So I think you might have to jump a little bit in your notes. I'm not sure how I arranged it. But again, the activity series is a tool, and I'm just going to jump to the activity series and we'll kind of work backwards from here. So you have 2 activity series. You have an activity series for metals, and you have an activity series for the nonmetals. So if you're dealing with metals, you only look at the one with metals on it. If you're dealing with nonmetals kicking each other out, then you only deal with the nonmetal ones. And if you look over here, we have really active metals at the top. So these are very reactive. And the ones at the bottom are very unreactive. So like lithium, rubidium, potassium, very reactive metals, stuff that is pretty dangerous to be around. If you think of the bottom though, copper, silver, platinum, gold, those are very non-reactive metals, and that's good. That's what we prize them for. That's why you wear jewelry made out of them. These metals last a long time. You know, gold basically doesn't react with anything. When they dug up King Tut's tomb, the gold was still in there, unoxidized. Whereas if you're looking up here, you know, if boys ever buy an engagement ring or something, you would not want to buy one of these metal engagement rings. It would burst into flame on your fiance's hand and like give her 3rd-degree burns. So these are not desirable metals for certain things. For reactions, these are very reactive, and very desirable. The halogen list is the exact same thing. It's just there's not very many halogens, so it's really short. But the very reactive ones are still at the top, and the very non-reactive ones, relatively speaking, are at the bottom. So here's just some information about your activity series. They're going to affect your single replacement reactions, and you may want to make a note, only single replacement. So you're not going to look at these with double replacement, synthesis, decomp, anything else, just single replacement. And when we say an activity series, it means basically reactivity. So if you're really reactive, you're at the top of the list. If you are reactive as a metal, you lose electrons easily. If you're reactive as a nonmetal, you gain electrons easily. And again, these are actually experimentally determined. Someone actually does reactions and sees how metals react, and then that's how they actually determine it. So what happens is any metal above it can replace anything below it. So elements further down cannot replace any elements above it. So basically, if we're looking at our list here for metals, lithium can kick out every other element listed, every other metal listed. If you look at silver, though, the only 2 metals he could kick out are platinum and gold. Those are the only 2 he's ahead of. And just some examples here. If we look here, so what we're looking at here is when you have this, we have aluminum. So the first thing you have to think about is, what is aluminum? You know, is he a metal or non-metal? He's a metal, and he's going to be trying to kick out the other metals. So he is going to try and kick out zinc. So for this to happen, aluminum must be higher than zinc. And you may want to just make yourself a note. For this to happen, Al must be higher than zinc. Then you go to your thing and find aluminum, find zinc. Aluminum is higher than zinc, which means he is reactive. And as you can see, we wrote and predicted the actual reaction. Remember, don't bring over subscripts and stuff that were there because of compounds. The only reason that chlorine had a 2 subscript is because it was bonded to zinc. So when you bring him over, he abandons that subscript and you figure out a whole new one. If we look on this guy, we have cobalt, which is a metal. So he's going to try and kick out sodium. And again, you may not want to, but for this to happen, CO must be higher than Na. So you go to your lovely activity series and you check and you say, okay, here's CO, here's Na. It's not going to happen. Cobalt is not reactive enough. So basically what's happening is chlorine is making a decision. Do I stay with sodium or do I go to cobalt? Well, in this case, sodium's the more attractive one, so he stays, and you write no reaction. And we'll just do one real quick with a halogen. So if we have fluorine plus salt, and we want to see what's going to happen. Fluorine is obviously the guy that's trying to do something, and fluorine is a nonmetal. So when you look on your little chart, you need to make sure that you're looking at the nonmetal side. And obviously this is a much shorter activity series. But fluorine is going to have to be higher than chlorine for it to happen, and that's who he's trying to kick out. He's trying to kick out the other nonmetal. You go check. Fluorine is at the top, so it can happen, it can occur, and you would get some sodium fluoride, and you would get chlorine gas. Now, a couple of things. Chlorine is in Brinkelhoff, so you need to make sure you do Cl2. You need to check your charges for sodium and fluoride. Sodium's +1, fluoride's -1, so that's okay. And then the final thing you have to do is you have to go back and balance your equation. So make sure you're practicing the single replacement ones. And good luck, and hope you are enjoying chemical reactions.